And so there's just some comics here. If you were in my class in 8th grade, you may have seen these before. I used to put them up all over my classroom. So we have a right triangle, and instead of hypotenuse, it's labeled hippopotenuse. That's stupid. Stupid joke. And then you have these three like dudes walking along, and these guys are just going straight ahead. And then Pythagoras is like, nope, I'm going to take the shorter route. I'm going to take the hypotenuse. And they're like, you're so cool, Pythagoras, because it's from the Pythagorean theorem. So I just thought I explained those jokes to you. I'm on a different computer. Oh, good. I'm glad you're on, Natalia. And the code is on. If you look at Google Meet, it's GEHBN. It's in the upper right-hand corner of my screen that I'm presenting. I think you can see it. So let's go ahead and go to our first slide. These are the things that we're going to be covering. And right now, I think it doesn't matter which tab you're in. If you're in the Google Meet, you're fine. If you're in the presentation, you're fine, because you're looking at the same exact thing. There's nothing to do on this slide. It's just me telling you guys what your test is about. Okay, so we are done with Unit 1, and in the first week of learning, not the first week of school. The first week of school we did like just a bunch of get to know you kind of things, and like playing with the different stuff that you log in. But the first week of learning, which was actually the second week of school, is we covered 1.1, segment length and midpoints. That was your first set of notes. And then the next week after that, which was actually the third week of school, and that's a little confusing, and I probably am going to change those numbers out because I'm not trying to confuse you, but with the WAGs, because that is weird. I might be able to change that right now. I think I'm going to try. I'll just take that off. We also covered interior and exterior angles. We covered isosceles and equilateral triangles. And then today I'm going to kind of go over classifying triangles with you. Okay, so that'll be something we're going to take a look at. And it's not updating to the slide, but it is updated on my screen. So I don't know why. That's weird. It's all right, though. It's not a big deal. These are the things that are on the test. Okay, so here's your first interactive slide. Everyone's going to go to their Pear Deck tab, and you're going to plot a point for me at the origin. So you have to remember, what does that mean? Where's the origin? Plot a point there. All right, and so I want to kind of see how many open dashboard in a new window. So I have 21 of 24 responses. So if I do show your responses, I think it is showing everyone's. It's like you all got it right. So the origin is at 0, 0. So if you do see that, that's what we're referring to. And so here's your next slide. And this is which of these doesn't belong. You're going to drag your dot to where you think there is something that does not belong. Okay, so I have 24 of 25 responses. Some of you guys are still moving your dots around, trying to decide where you want to put your dot. It's a super difficult question, I know. Uh, all right, I'm going to go ahead and show your responses. So most of you said that me as a potato laying down did not belong, and you would be correct. Okay. These other three things are all math related. A potato has nothing to do with math. These other three things, not only are they math related, they're all about the distance formula. So if you start with a good old right triangle where you have A and B are the legs and C is your hypotenuse, and then you look at the Pythagorean theorem from that, A squared plus B squared is equal to C squared. From this equation, we get the distance formula, because if I take the square root of both sides here, then I get C is equal to the square root of A squared plus B squared. And if this is a triangle in the coordinate plane, well then to get A and to get B, all you have to do is subtract the X coordinates and then subtract the Y coordinates, and then you'll get those values. So these things are all related. A potato has nothing to do with anything else. All right, here's your next question. And this is the one that I think it started on for a lot of you guys because I had it on the wrong slide. But now I do want you to go and work this one out. It says, what is the exact length of the segment with endpoints at the origin and at the point 3, 6? You might have to do some work on a piece of paper to figure this out. That's totally fine. And you'll have to come to your Pear Deck tab so you can choose the correct answer. There's 4 possible choices. I have 11 of you that have responded so far. 6 of you have gotten it correct. Most of you are picking the right answer, so that's a good thing. I need 10 more responses, and then we'll go over the correct answer. All right, I need 6 more responses. We're almost there. I have 23, I have 27 responses. And for the number of us that are in the meet, we should have 30 people in the Pear Deck review. So there are some of you that aren't logged into it. There's a few of you that aren't. So if you are one of the 3 that still need to log in, the code is in the upper right-hand corner, and you go to joinpd.com. All right, I'm going to go ahead and show you responses because I have most of you that have responded. And so this is what we decided as a class. The most popular answers were B and D. Square root of 45 and square root of 21. So we're kind of between these two. And maybe that's because some of the other problems we've looked at like this, like on the reteach, the answers were the square root of a number, which doesn't necessarily have to be the case, because if it was a number you could take the square root of, then it would just be a simple integer answer. Nobody likes C anymore. Nobody likes A. A and C are not the correct answer. It is B or D. So let me go ahead and present something else to you so I could show you the work for this one. I know you can't see it yet, but I'm intentionally not showing it to you yet. Okay, so I'm going to share a different tab with you. So come back to the Google Meet. All right, so those of you that are on Pear Deck, please come back to the Google Meet. And I want to show you how we solve this. Okay, so I'm going to start with the Pythagorean theorem. And from that, if I take the square root from both sides, I get C is equal to the square root of A squared plus B squared. And then to figure out what A and B are on a triangle that I can't see, but I do have the coordinates of the x's and the x coordinates and the y coordinates of the 2 points that make this line segment. And it's when you subtract them, we can also call that the change in x or delta x. We can also call that the change in y or delta y. That's a Greek letter. It represents a Greek letter delta, kind of like a D in English. So the change in x, 0 and 3, the difference between them is 3. And the change between 0 and 6 is 6. And then I square these. So if I'm going to simplify this, does anyone want to change their answer? Okay, it is one of the square roots, but it's if we come back to what we're looking at here, what can I simplify the square root of 3 squared plus 6 squared? What does that simplify to? Some of you might want to change your answer. 5 of you might want to change your answer. Good. Yes. Okay. 2 of you should change your answer. I'm going to show the rest of this. So 3 squared means 3 times 3, and 6 squared means 6 times 6. So that's 9 plus 36 or 45. It's the square root of 45. And I'm going to leave it just like this because 45 is not a perfect square. So if I take the square root of 45, I'm going to get an irrational number, and I want to leave my answer as exact. But if I did want to round my answer, let's see. If I wanted to round my answer, I want to show you like a calculator real quick. So let me just go ahead and search up a calculator. Because I think there's a question on the test like this. So like say I took the square root of 45. So if I had to choose an answer that was close to the square root of 45, I would choose something like 6 7/10, because that's a rounded answer. It's approximately that. Okay. So that's just something to keep in mind, is that you can approximate an answer or you can leave it exact. All right. That was the big calculation problem. There's one more. It's a big calculation problem, but it's really not that bad. Okay. So what is the midpoint of the segment with endpoints at the origin and at 3, 6? So you're going to come back to your Pear Deck tab. And again, it's a multiple choice. You're going to choose what the midpoint of that segment is. So you can use the formula for midpoint, where it's capital M, and then you take the average of the x value, the x coordinates, and then you take the average of the y coordinates to get your coordinate of the midpoint. Or, because you have a picture, you should be able to kind of like, whatever you do get, you know, where is halfway between the two endpoints? You know, if I get something that's down here, I probably made a mistake. So like those of you that are somebody choose 0, 9/2. So 0, 9/2 would be like way off the graph over here. The midpoint of this segment has to be on this line. It has to be in the middle. If you chose 9, 2, 0, well, 9, 2 is about 4.5, which is over here, and 0 mean my midpoint is here. So it's definitely not A and B. So good. We got rid of those A and B's. That was wrong. A and B were wrong. It's definitely C or D. And I'm going to go ahead and show you how to do this. And we're kind of torn, so I won't make you give your answer just yet. But so the midpoint, the average of the x's and the average of the y's. Well, our x values are 0 and 3. Our y values are 0 and 6. So it turns into 3/2 and 6/2. And if you simplify that, you would have 3/2, 3, or 1.5, 1 5/10, 3. So the correct answer, which of those, C or D, matches is the same value as the answer here that I'm presenting to you. 7 of you have it correct. 14 of you should change your answer. And I have a picture of a triangle DEF, because it has the 3 angles, D, E, and F. And then I have a little arrow. It's the ray. It's being extended out from F to create an exterior angle. That's the angle of 150 degrees. That's its measure. That'd be the angle of measure. 150 degrees would be the measure of angle. You could call it DFG or GFD. But what I want to know, and you're using the exterior angle theorem, if you add together the measure of angle D, okay, right where D is, that angle, and the measure of angle E, right there where that angle is, what sum do you get? There's a rule about adding those two angles together and what it's equal to. It's called the exterior angle theorem. So I'm going to show you guys what you're coming up with so far. So it kind of takes our data and it's turning it into, it looks like maybe a Could be a box plot. So you have a median of 90 is the middle answer. Our high end is 150. The low end is 1. It's kind of jumping all around. I didn't know I was going to show your answers this way, which is kind of interesting. But do you guys see where the reddest dot is? Because that is the correct answer. 150 degrees is correct. So you should change your answer to 150 because when you add these two angles together, D and E, they equal 150 degrees. I don't know, we might actually make it through our lesson. We'll see. Classifying triangles. We haven't really done this yet, and so that I wanted to go over this with you. It is review, but I wanted to cover it with you specifically. That classifying triangles can be done by side length is one way. So if all three sides are exactly the same length, and you have these little tick marks here to show that they're all the same length, we call that an equilateral triangle. If you have a triangle where at least two sides have the same length, so the little tick marks are just up here on two sides, but not on the third one. I mean, they could be, but it'd be equilateral. But if this is the case, it's an isosceles triangle. Two side lengths are the same. Equilateral triangles are also isosceles triangles, but isosceles triangles are not always equilateral triangles. All right, now the last possibility is all three side lengths are different, and then we say it's scaling. It's scaling. All right, you're going to draw a picture. Go back to your Pear Deck tab and draw a picture. Draw a scalene triangle. I'm going to show some responses. 3 different side lengths. Yep, that's scaling. They're working on it. They're working on it. Oh, whoa, that was a circle. 3 different side lengths. Yeah, we're getting there. It's not connected yet. These are scaling, 3 different side lengths. Oh, that's a very nice and pretty one. When they deleted it. Okay. So real quick, we're just going to cut the lesson kind of short. This is the last slide I'm going to go over with you guys because we do have 5 minutes left. Okay, classifying triangles by angle measure. So you can also classify triangles by their angle measure. If all 3 angle measures are less than 90 degrees, and the screen that I'm presenting is covered up, but if I don't move my mouse, it'll go away. There we go. If they're all less than 90, we say it's an acute triangle. Like my joke yesterday about acute angles, less than 90, so cute. If one angle measures exactly 90 degrees, that is a right triangle. If one angle measures more than 90 degrees, it is an obtuse triangle. And that matches up with obtuse angle, right angle, and acute angle. So if they have, you know, if all 3 are acute, then the triangle is acute. If one angle is 90, then the triangle's a right triangle. If one angle is more than 90, it's an obtuse triangle.